We're in Unit 7, Quadratic Functions and Equations. We'll be covering Lessons 7 and 8, Equivalent Quadratic Expressions, and Standard versus Factored Form. Turn to page 66, complete the warm-up. Explain why the diagram shows 6 times 3 plus 4 equals 6 times 3 plus 6 times 4. Draw a box, a rectangle. We're going to take that first term, 6, and we're going to place it on one side of the rectangle. I put it at the top here. And then we're going to take the binomial 3 plus 4 and put it along the side. All right, now we have 2 rows and 1 column. So we're going to go down and across and take the 6 times the 3, multiply those together. We're distributing multiplication. This would be like 6 times 3 and 6 times 4. All right, again, go down and across, 6 times 4 and 6 times 3. And we'll add those together. So that would be 18 plus 24. We're going to simplify that. All right, you're asked to explain, and this may be something new to you. A sample response would be the entire diagram represents the product of 6 times 3 plus 4. The upper half represents 6 times 3, while the lower half represents 6 times 4. Question number 2, you're asked to draw a diagram to show that 5 times x plus 2 equals 5x plus 10. Again, we know the distributive property. We can distribute the multiplication of 5 to both terms. So that would be 5 times x, that's 5x, plus 5 times 2, that would be 10. But we're going to draw a diagram and use the box method to show how we can organize that multiplication when we're talking about a monomial, one term, and then a binomial, two terms. All right, we're going to draw that diagram. This time I'm going to put it sideways. There's no right or wrong way to do this. Just put one of the terms, that first thing that you're multiplying, along one side. So I'm going to put the 5 on the left and the x plus 2 along the top. All right, now we're going to go down and across. 5 times x is 5x. Down, and then bring that 5 across. 5 times 2 is 10. So your solution is going to be 5x plus 10 right here. All right, on page 67, Activity 1, drawing diagrams to represent more products. Applying the distributive property or expanding 4 times x plus 2 gives us 4 times x plus 4 times 2, which is 4x plus 8. So we know the two expressions are equivalent. We can use that rectangle or box method with side lengths x plus 2 and 4 to illustrate multiplication. Now draw a diagram that shows n times 2n plus 5. So draw the box, place n on one side and 2n plus 5, these two terms on the other side. And then we're going to go across and down, multiply those two terms together. So what is 2n times n? That's going to be 2n squared. Now go down and across. What's n times 5? That's going to be 5n. So our solution when we multiply this monomial to this binomial is 2n squared plus, we're adding those terms that we get, plus 5n. We're still on page 67. All right, use the distributive property to write an equivalent expression. If you get stuck, consider drawing a diagram. So we know the distributive property. You can use the distributive property, or you can use the box method. 1/3 of 6, or 6 times 1/3, I'll put 6 over 1, times 1 over 3. That 3 goes into 6 2 times, so that simplifies to 2, and don't forget that there's an n there. Plus 6 times 2 is 12. Two n plus 12. All right, when you're distributing multiplication with one term or two binomials, take it slow. Have some kind of method. Go slow, don't go too fast. 5r times r is 5r squared. And then 5, let me write this over here so we can see the multiplication. 5 over 1 times 3 over 5. 5 over 5 is 1, so that's going to cancel, and we're just left with 3. So it should be 5r squared plus 3. Okay. All right, p times 4p. We're going to have 4 and then 2 p's that we're multiplying together. So that's going to be 4p squared plus 9p. And then finally, the last one, we have the single term on the right. We're still going to distribute that, meaning we're going to multiply that w to both terms. Just going to go in this direction. So 1/2 w times w is 1/2 w squared plus 7 times w. Now here's a diagram of a rectangle with side lengths x plus 1 and x plus 3. We're going to use that diagram to show that the binomials x plus 1 times x plus 3 equals x squared plus 4x plus 3. All right, go down and across. X times x is x squared, not 2x, but x squared. Go down and across. 3 times x is 3x. All right, again, go down, multiply that x times 1. That's going to be 1x. You can write it like 1x, but 1 is an identity. So we'll end up not seeing that 1 in front of the x. It's just going to be x. Okay, and then go down. 3 times 1 is 3. Now these two numbers that are diagonal from each other are like terms. We have 3x plus 1 more x. 3 plus 1 is 4. That middle term is going to be 4x. First term is going to be here, x squared. And the last term is going to be here. And we're adding those together. Now typically when you write this trinomial answer, you're going to put the squared term first, the linear term second, and the constant last. All right, let me erase this so you can see. Just repeating what you saw earlier, how we're going down and across To get these terms, the diagonal terms add together to give you that middle term. All right, now draw diagrams to help you write an equivalent expression for each of these. So think about what x plus 5 is when we square it. Squaring means that we're going to multiply this term, the x plus 5, to itself 2 times. So I'm going to write that out, expand it, x plus 5 times x plus 5. Now you can write the box method, or you can distribute the x to both terms, distribute the 5 to both terms, and then add them together. I'm going to show you a different method besides the box method when you have two binomials. I'll take the first term of each of those, multiply them together. That's going to give me my first term in my answer. X times x is x squared. Then I'm going to take the outer terms, which is going to be x, looking at the outside of all of this. X times 5 is 5x. Okay, the inner terms, 5 times x is 5x. And then the last, 5 times 5 is 25. Now I'm doing it without the box, and I call this the FOIL method. I want you to refer to it as distributing multiplication of each term in that first binomial into each term of the second binomial. FOIL stands for first. I multiplied the first terms, outer, inner, and last. Don't forget to add these two together. That gives you 10x. So our answer when we simplify it is x squared plus 10x plus 25. All right, B, we have one term. We already know how to distribute one term. Multiply 2x times x, that's going to be 2x squared. And then 2x times 4, 2 times 4 is 8. And we have that x. Don't forget about the x, so go slow. Then add those two terms together. 2x squared plus 8. All right, let's try the next one with the box method, just to get a look at that again. All right, I've got 2x plus 1. Put those terms across the top. You can put them along the side, it doesn't matter. And then x plus 3. I'm going to put those along the side. So I have 2 rows and 2 columns. 2x times x is 2x squared. 1 times x is x. 2x times 3 is 6x. And 1 times 3 is 3. These two terms, 6x and x, add together to give you the middle terms. So 6x plus 1x is 7x. The first term is 2x squared. And the last term is 3. And then remember, we'll be adding those 3 terms together. Two x squared plus 7x plus 3. All right, let's try the last one using the first outer, inner, last multiplication method. So the first term in each binomial is x times x. That's x squared. Outer, I'm going to go to the outside and multiply x times n. Put those two letters in alphabetical order. They do not multiply together, so you just have to write n times x. Enter, go inside, multiply m times x, and then the last term in each binomial, multiply those together. M times n. All right, then look and see if anything can be combined. It can't. There are no like terms, so we end up with 4 terms here. X squared plus mx plus nx plus mn. Typically, these two middle terms add together, but we have variables, so it changes this just a little bit. All right, page 68, we're going to write equivalent expressions without drawing a diagram. So this time I'm going to refer to the first, outer, inner, last. First, terms multiplied together, x times x gives me x squared. Outer, x times 6 is 6x. Inner, 2 times x is 2x. And last, 2 times 6 is 12. Now this time, these two numbers are like terms. These two terms in the middle, they are like because they are linear terms. They both have an x to the first power. So 6x plus 2x is 8x. The last term is 12, and the first term is x squared. Remember, a quadratic has to have a squared term in it. Nothing larger, but it has to have that squared term in it. And then b, again, first, x times 2x is 2x squared. Outer, x times 10 is 10x. Inner, 5 times 2 is 10x. And then last, 5 times 10 is 50. All right, now this time these two are like terms, so they add together. 10x plus 10x is 20x. Okay, the last term is still that constant term, 50. And the first term is the squared term, 2x squared. Let's check our work. Okay, it looks like we got this one correct. And then the second one, we got correct also. Go through the summary and glossary. Look at the method that we learned today. We'll call this the box method. How to multiply either a monomial times a binomial or two binomials together, or even bigger than that, but we're going to start with multiplying a binomial times a binomial. Also go over distributing with the FOIL method. We're distributing multiplication of both terms in that first binomial to both terms in the second binomial. Okay, so there are two methods that we use today. All right, for a warm-up on page 76, solve each equation mentally. So we're going back to solving equations. We want to have our variable on one side and our constants on the other side. So I'll go ahead and subtract 40 from both sides. You could start by simplifying 40 minus 8, but I'm just going to start by subtracting 40 from both sides. What I'm left with on the right is n, bring down the equal, and then 40 minus 40 is 0, bring down the negative 8. This is not the only way to do it. So you can start by saying 40 minus 8 and then subtracting 40, but you should still get n is equal to negative 8. All right, solve this equation mentally. You can take negative 100 and add 25 to it. We have a positive plus a negative. opposite signs, we subtract. 100 minus 25 is 75, and the biggest absolute value is 100, and it goes with the negative, so our answer is going to be negative. We have more negatives than positives. Equal 25 minus n. So we simplified the left-hand side. We still have this 25 by the n. So let's subtract 25 from both sides. And we get 25 minus 25 is 0. Bring down the minus n. Bring down the equal. These are both negative this time, so we're going to add them together. 75 plus 25 is 100. Okay, and this is negative. Now what we need to do, we can't have a negative variable. We're going to multiply both sides by -1. Distribute a -1 throughout this equation. Two negatives are going to make a positive. So now we have positive n equal, two negatives make a positive, positive 100. Now you could have done this mentally just by saying there's a 25 on both sides and subtract that 25 from both sides. You would have gotten negative n equals -100, and then you would have multiplied both sides by a -1 to make both of those positive and still gotten n equals 100. All right, now let's look at this one a little closer. You see how there's a 3 on both sides? Okay, we can go ahead and subtract that 3 from both sides and get n equals -1/2. That's our solution. Same thing here. We have 72 on both sides. Let's subtract that 72 from both sides, and we get -n equals 6. We can't have a negative n, so we're going to multiply everything by -1. In other words, every sign in every term is going to change to its opposite. So n is equal to -6. All right, we want to show that x minus 1 times x minus 1. I'm going to write this a different way. This is x minus 1 squared. We're going to show that this is equal to x squared minus 2x plus 1. All right, you can use the distributing multiplication. We call that first outer inner last, or you can use your box method. Okay, the sum of the partial products, x times x is x squared, -1 times x is -x, x times -1 is -x, and -1 times -1 is +1. These two numbers are going to add together. -x plus -x, we've got two negative x's, or -2x. First term is here, x squared. The last term is here, 1. If you apply the distributive property, which is first outer inner last, a shortcut acronym, it's going to give us the same thing. All right, more practice finding products of binomials, and we call this the product of differences. You're going to see something happen here. All right, let's take that first term, x times x, and distribute that multiplication is x squared. Let's take the outer, x times -1 is -x, and then the inner, x times +1 is +x, and then last, -1 times +1 is -1. Now notice that these two combine together to give us 0. X plus -x is 0. So I'm not going to write that. They just cancel each other out, and you get x squared minus 1. Now this is called a difference of squares because x squared is a perfect square, and 1 is a perfect square. X times x is x squared, and 1 times 1 is 1. But you get that by multiplying the same binomial, except you've got plus in the first one and minus in the second one. All right, let's try this one, B. First term, x times x is x squared. Okay, let's go ahead and do the last. 3 times negative 2 is negative 6. And let's do this mentally. Do those two middle terms. Outer, 3 times x is 3x. I'll put it over here. And then x times negative 2 is negative 2x. Combine those together. 3x minus 2x is plus 1x. I'm just going to write the 1x this way. So this is what I have for my second solution. All right, now we have x minus 2 squared. So you can write that out. X minus 2 times x minus 2. And let's do our first term. X times x is x squared. Let me go ahead and do the last. Negative 2 times negative 2 is positive 4. And then the outer, let's take that x times negative 2 is negative 2x. And another x times negative 2, got another negative 2x. Add those together and get negative 4x. All right, let's check our work. X squared minus 1, difference of squares. Okay, now we're going to multiply these two different binomials and we get a trinomial, x squared plus x minus 6. And then finally, x minus 2 squared, we get x squared minus 4x plus 4. All right, what is the standard form? Standard form, all of these are written in standard form. So you have to have a squared term. And this one has a constant at the end, but it doesn't have that linear term in the middle. That's okay. As long as we have the squared term, the constant term, or the linear term, could be, or it is, 0 x's, and we don't write the 0. Okay, so that's missing in the middle. This one has the squared term, the linear term, and we have no constant. Okay, this one only has the squared term. So the middle term, or the linear term, we have 0 x's, and we have 0, and I'm going to use c for constant. Okay, so we don't write those zeros. Okay, this is a quadratic equation because it has a squared term, a linear term, and a constant. So if you have all three, we typically write them with the squared term first, linear term next, and the constant last. But they don't have to be in order to be in standard form. They just have to have a squared term. This one has all three, and this one we have the x squared last. These are not in standard form. It just means that we have it pulled apart into factors. We have 2x plus 3, and we have the x being multiplied to that binomial. Okay, we could distribute it, and then we would have it in standard form. This is pulled into two factors. This is pulled into two factors, and then we're going to add 1. So these are not in standard form. We have some work to do to simplify it and distribute that multiplication before we can put it into standard form. And then finally, the last, we have two binomials where we need to distribute that multiplication in order for it to be put into standard form. All right, what is the standard form and what is the factored form? So again, some other examples of standard form. Look at those closely. We have a squared term. Sometimes we have a linear, sometimes we don't. Sometimes we have a constant, sometimes we don't, but we have to have that squared term. And then sometimes that squared term things are kind of out of order, but it's still in standard form. Factored form is when it's broken into two pieces that can be multiplied together, or maybe even more than two pieces, like this one, where we're adding something at the end. But we have to do some simplifying to get it into standard form. Again, standard form, not in standard form. Factored form means we have two or more things that we can multiply together to get it into standard form. Go through your summary and glossary starting on page 78. Go through those examples, highlight important vocabulary, look at the methods that we've used to multiply binomials or binomials and monomials, and then complete the practice and the warm-ups for this lesson. Do this in your workbook. We're going to add question number 1 to this, and we'll check your workbook tomorrow.